Hey guys, welcome back to Study with me, and today I'm going to show you guys how to solve this question about Lewis diagram representation and also formal charge and hybridization. Okay, so let's get right into it. So the first question is going to ask you, using formal charge, determine which structure is the most likely correct structure. And okay, so you know a structure is the most likely when the number of atoms which have formal charge is smallest, right? So that'll be the most likely. And now we're going to find out, okay? And because in these two diagrams, you can see that the hydrogen is represented the same way. They're both bonded with a C, so we can skip it out for now. And so we're going to consider the 2C and the oxygen only. Okay, so I'm going to call this the first and the second Lewis diagram. Okay, and in the first diagram, you can see that the formal charge for each atom is like this. So the formal charge is equal to the number of valence electrons and minus the number of assigned electrons. Right? So we got here, we're going to consider this carbon first, and the valence electron of carbon is 4. And it's the same for this carbon with an X. For oxygen, it's 6. And I'm going to minus the assigned electron in the first diagram. In the first diagram, you can see that carbon is bonded with 2 hydrogen and another carbon. And we're going to count the bond, right? We're going to see 1, 2, 3, 4, right? 4 assigned electrons, because for each bond, we're going to count as 1 electron. And it's going to be 4. And for this carbon, it's going to be 1, 2, 3, 4, right? It's going to be 4. Right? And now we're going to look at this oxygen atom, right? As you can see that it has 1, 2, 3, 4, 5, 6 electrons. Remember that for each pair of electrons like this, we're going to count as 2 electrons and 1 electron in the bond. So it's 7. So the formal charge would be 0, 0, and minus 1. Right? And for the second diagram, we're going to do the same thing. Okay, let's just say this is the formal charge. And for the second diagram, I'm going to do the same thing all over again. And there's 4, 4, 6 minus the carbon here. We're going to count 1, 2, 3, 4. 4 electrons. For this carbon, it's 1, 2, 3, 4, 5. There's a difference. And for this oxygen is 1, 2, 3, 4, 5, and 6. 6. So as you can see that, it's actually like this. So looking at formal charge, you can see that here it has 1 atom with formal charge. In both cases, you have 1 atom has formal charge. So we cannot only rely on this We cannot like only rely on this statement. So we need to account for another thing, which is electronegativity. So here, just let me change the color for a little bit. Because looking at the periodic table, right, we can see that oxygen is more electronegative than carbon. So the charge for oxygen will be negative, right? So oxygen will be more likely to hold a negative charge. And looking at this, you can see that this case is much more likely. So you can see that the right diagram would be the first one, right? So the correct structure would be the structure on the left. Okay. Now I'm gonna move to the next question. Okay, just like that. For carbon atom X in the structure you chose, what is the hybridization around the atom, right? We chose this structure, so keep that in mind. We're not gonna care about the structure. What is the hybridization around the atom? And to determine the hybridization, right, we need to count the number of electron domains. In some textbooks or some sources online, they might call it electron clouds. And in my previous video on molecular geometry, I also called that electron clouds. But basically, it can be the areas that has electrons. And we're gonna find it out, okay? So let's look at this element X right here, right? Now we're gonna count the number of electron clouds around it, and in order to find this number of electron clouds, we're gonna count the number of sigma bonds plus the number of lone pairs of electrons, if there are any. So here we have one sigma bond, and one sigma bond. I'm gonna delete this because that would be a little bit confusing. Okay, so that would be like 3 domains of electrons, right? So we have 3 domains of electrons. And then we can conclude that the hybridization around carbon X is sp2 because it has 3 domain of electrons, so it's going to be sp2, right? So the answer would be sp2. For this question is on the left. I'm gonna write the answers here. I know it, I'm just going to delete it all over again. How many sigma and pi bonds has the atom formed? So you can see that, okay, let's take a look at this all over again. So in double bonds, right, let's have a quick revision. So in double bond, there is one sigma bond and 1 pi bond. And for single bond, they only have 1 sigma bond. So therefore, by counting the number of double bonds and single bonds around this carbon X, we can determine the number of sigma and pi bonds. Okay, so we can see that there is 2 single bonds and 1 double bond. So that would be 3 sigma bonds, right? Sigma bond. And we only have 1 double bond, so it's going to be 1 pi bond. Okay? And a hydrogen ion attaches itself to the enolate ion, which is this whole thing, creating this. I don't want to find it right now. Find its name. Draw the Lewis diagram of the new molecule. And okay, so first just let me delete this whole thing first. Okay. So the hydrogen ion is H+, right? So it is obviously positive. And now, so it's going to be attached to a negative ion, right? And you can see that our ion is negative, so it satisfies the deal. However, we gotta take a look at where will the hydrogen bond with. And we can easily see that it is very likely to be the oxygen, because you see that because in the question A, we have already found out that the formal charge for oxygen would be -1, right? So it's going to attach to this oxygen atom because it is negative, right? So in free response questions, we're going to write like this. This is how you account for justifying your answer. Okay. The hydrogen ion will attach to the negatively charged oxygen. And now we're going to draw the Lewis diagram of it. So first we're going to draw all of the bonds. Okay. And now the hydrogen will bond with the oxygen. And now to satisfy octet rule, we're gonna add 2 lone pairs of electron into our oxygen atom, and this is our Lewis structure because it is not an ion anymore, so we don't need this bracket. Okay, and thank you for watching this video, and I hope that after this short videos you may understand about the Lewis structure, hybridization, and how to count the number of sigma and pi bonds inside a molecule. And this is just a quick revision videos, and to delve further into the theory, I really recommend you guys to watch my other videos and also read some books. I really recommend the Princeton Review chemistry book, and that's actually where I got this question from. Okay, so that's the end of the video, and remember to subscribe to this channel in order for more videos like this. And okay, it's the end now. Bye bye.